Okay, so this is showing the basic principle of Henry's law, where the increased pressure of the gas is going to increase the dissolution into the liquid. So this is the actual equation. So you can see that solubility is equal to your constant, which is different depending on your material, times your partial pressure. So this is kind of what I was trying to explain to the student, was that while technically, yes, you can increase the volume and the solubility can, the number of molecules can increase, but it's all about proportions. So that's why this is multiplication. It's because everything is in direct proportion of each other. So right here, it's doubling the pressure. So when you double the air pressure, you double the solubility into the gas. So the proportion always stays the same, even if the numbers change. And then here, just again, showing the equation for Henry's law. So concentration, your constant, and then your partial pressure. And then here you can see that they're directly related. So as opposed to Boyle's law, which is indirectly related, which means they do the opposite, this is directly related. So as pressure increases, solubility increases. And another thing to note, the volume is the same in all of these examples. Every example that I've shown you so far, the volume is held constant, because when you're working with gas law, which I put into the chat, which unfortunately can't see in the video, but PV equals nRT is the gas law. That's how we do all of the equations in scuba. So you have to, if you want to find two variables out, you have to hold everything else constant. So you wouldn't be able, without doing complex calculus and things of that nature, you can't do 3 variable problems. So the whole thing with the volume is it has to be held constant in order to be, the temperature and the volume have to be held constant in order to see how solubility and pressure are related. Here's a real world example of actually making that calculation and finding the equilibrium constant for, this is a natural gas. So methane is the one that they're looking at right now. So methane gas. And then here's actually how it is derived, obviously a little more advanced than I would ever give to the open water students, but it is interesting to see how a gas law is derived. But even in this example, you can see there's no volume to calculate the solubility, because volume has to be held constant in order to do these calculations. And then finally is just a list of different coefficients. So that K value that I was talking about earlier, these are all your different K values, and it can change depending on your critical value and things of that nature, which is the difference between these two numbers. But yeah, you can see that each one has an individual coefficient that dictates how well it dissolves into a liquid. And I think most of these would be for water. But yeah, that's what I had for Henry's law.
So excellent. I'm going to keep recording, and I'm just going to go over what the test question said. According to Henry's law, gas solubility increases, more gases are dissolved with, and the options were volume, pressure, heat, and latitude. So given that explanation, the only correct answer would be pressure, right?